Hello, thank you for the warm welcome. I'll be talking on the kind of a little bit softer side, considering the talks we had before on different tracks, mainly about the management side. By no means I'm not a guru of management. I'm one of you, so I'm a machine learning engineer, software engineer, and so on and so forth. I just worked on many projects and led some groups, and I have some thoughts about it, because we have a big problem. We have great people in the industry. We have great frameworks. We have a lot of tools. We have a lot of hardware, but still we have problems with our projects. And this is kind of a it's not totally full collection of what I've learned. I just want to start a discussion and share some thoughts with you about it. It's on the software side. You don't have to be a manager to it. It's also for if you're a developer or data scientist, machine learning engineer, you can take some things from that, because I'll be talking about the processes, I'll be talking about teams, I'll be talking about data, so many things. By the way, how many of you are actually, can be considered some form of managers, can be line managers, team leaders, or CEOs as well? Okay, so like 1/5, I guess. Cool, anyway, I hope I won't bore you to death then. So anyway, who am I? Short introduction is more for kind of reference. You can contact me via Twitter, LinkedIn, and these slides will be on my GitHub. There will be a lot of references, but you can download them from my GitHub later. Used to be software developer, and then I did some maths PhD, and then it's called now data scientist or machine learning engineer. So I kind of stick to that. But I have a slogan: I code, I do maths. So both of that. So if you want to chat about it with me, that's cool. And also I used word educator because I still didn't get used to it, because I teach both at a university, also in kind of commercial setting as well, and also sometimes give a talk places like here. So I guess I'm educator a little bit as well. Anyway, this is what we have nowadays. So depending on what you read, a large number of in kind of data world, because I'm not distinguishing now big data, machine learning, data science, and so on and so forth. Basically, projects that have some form of data wrangling in it fail. This is kind of the reason of failures, and how they fail is kind of different. They sometimes just get, I don't know, postponed. They get not used, but a large number of them fail. Is it bad per se? Well, first of all, no. It's not bad, because you don't have to or shouldn't think about machine learning like it's not like building a house. It's if your project fail, that's actually good sometimes, because I mean it's closer actually to science. So in science we like to fail, because we're actually proving that we're wrong more often than proving that we're right. I mean, we're actually mostly proving that we're wrong. So first of all, the big number is not that bad. It means the problems are hard, but also we have many additional problems in the industry, and they're mostly managerial kind of related or organization related problems that make a project fail. And this is because basically the data stopped working. Maybe I'll just, sorry. Oh, it works now, I think. Okay, I think I switched it off. Anyway. Okay, so looks familiar to you. So many times you probably felt like this guy here, that you're kind of doing something, but it kind of feels wrong. so technically we are kind of moving forward, but the means of transport is not great. And why that happens? So I will tell you why the process differ. I will tell you a little bit, still talking about who are you anyway. So what's machine learning and what's data science and what do you need on your project? I can show you what we cannot see really, what are the costs of the problems, what should you look for, and how the team differs. And I kind of try to structure this talk in kind of problem solution kind of idea, because not to just get into a rant saying that, oh, everything's bad. It's more just, everything is bad, but we can fix it somehow. So, okay, bear with me. So first of all, about the process. So you probably have seen some of these graphs in kind of this shape or form. The first one is what is called crisp DM, and it's quite old actually as well. And the other one is Scrum. And so we have circles there, but that's where the kind of similarities stop. So on the right, or sorry, your left, sorry, you have the you have crisp DM, so how usually we conduct the data science project, and it's a cyclical project, a process around the data really. So first of all, we talk to business, then we have some data understanding, data preparation, modeling, evaluation, and deployment. And that's kind of is getting done in the circles most of the time. The big difference, what my colleague reminded me, is historically when this got told, because DMs here stands for data mining, so that's quite old. So historically when people were taught that, the problem here was that each of the blocks tend to take like 3 months or something like that. Nowadays, it's actually got agile. You actually do those iterations very, very quickly, but still in most of our projects related with data, we have to do all the steps. Whereas Scrum, it was designed for, it's like a factory. So basically you know what you're building and you just want to kind of modify it and push it as fast as you can. So as you can see here in the Scrum, you don't have, for example, business understanding part or data understanding part. You just have to push forward. So that's the idea of Scrum. And this is why in many organizations Scrum fails. I don't want to say that Scrum is bad or something like that. It's just, it's designed for producing things we know how it should look like. So basically like web pages, or this button should be blue and do this. We know what we're doing. Whereas with data is we have at most hypothesis that we're saying, oh, there is some value in this data that we can prognose our prices or something like that, or prognose our demand, but it may not be there, or it can be something completely different. So with Scrum, how you plan the Scrum, is quite a problematic for data science teams, and often data science and machine learning and big data teams are kind of pushed into the Scrum without the understanding of that this is, so the crisp or this kind of data cycle is the real process, how you work with the data, and there is much into it. As well, there is also one thing that is a little bit of misunderstanding kind of career-wise, which I kind of move forward to as well in the next slide, is that a lot of data-driven problems are not only technical problems. They are related to organization, they're related to people. We actually talk a lot. So actually people working with data have to talk to business people. And that's a little bit of a cliche nowadays in the IT industry, that you think about developers like people closed in a cellar and coding, whereas it's not a fact in like a data world really, because if you do that, you basically get business people the answer they already know most of the time. Okay, so so the process differ. So we should use slightly different processes. Oh, the answer here is anticipating that question. Yeah, Agile is not bad per se, just Scrum doesn't work too well with the data. For instance, we use Kanban quite often, and it works much better because you're much more flexible with Kanban than with Scrum. So that's the answer here. Next, who actually is data scientist or machine learning engineer or data engineer and so on and so forth? Often, companies very much overlook who they hire for and what necessities they have. So this is actually what kind of the broad data team should look like. So we're starting from kind of data analytics and then data science. You know, well, I kind of distinguish, because people say, oh, what's the difference between data analytics and data science? I use the kind of comparison that data analysts work at the data, they know what's in the data, and data scientists work on the data that they don't know what's in the data, basically. So that's the main difference, in my mind at least. And okay, but how they differ from machine learning engineers? Machine learning engineers are people that actually have more in common with data engineers and software engineers and sometimes DevOps engineers, that basically take models that they know they're kind of good, and they torture it to a level of kind of them being good and useful for the business. So you don't necessarily have to do a lot of data science thing and reports and so on and so forth. You just have to push the model to the limit, and that's kind of the definition, the modern definition of machine learning engineer versus data scientist. I'm not saying here this is the Venn diagram, so you have overlaps here. So it's not like if you're a data scientist, you will not torture the model or you will not deploy it. That's not true. It's just depend on the company, but you will probably spend more time on understanding data if you're a data scientist and more time on torturing models when you're a machine learning engineer. And also, when you're in machine learning and you deploy it and give it to the production guys, then some backend will be involved, some DevOps will be involved, and some data engineering will be involved. And this is actually, when you look at those diagrams, this is pretty much the mature data team you will need in your organization. So if you have just 1 or 2 bits of this kind of diagram, you will likely fail because you're missing something. Because data scientists or even machine learning engineers are not really good DevOps, for instance. So that's, you have to remember about it. Okay, going kind of more deep into it, this is kind of more reminder or me saying that read this paper, basically. There is a nice paper which is from NIPS from 2 years ago, I think. I don't remember exactly. It's called Hidden Depth in Machine Learning Systems. And this is what they show. This is the kind of the most interesting and most kind of expressive picture of how the systems really look like. And the stuff we're super excited about is the yellow one in between. And we talk about this a lot. I mean, we want to have the best models they are and so on and so forth. But actually, most of the time we spend on the engineering stuff. So at least when we want to deploy the models. So bear in mind that, for example, in an organization, when I listen to like Amazon or Google talks, they say from they only do modeling for, well, the models, machine learning models, they only do for like 5 to at most 20% of the time, and rest of the time is some form of data wrangling or deployment or coding in general. So that you have to remember about that, and you should have all the blocks here. So I don't have time to go into it in detail, so just go and read it, but it's very, very informative. Also, they spend quite a lot of time of what we've heard today already, the problem of garbage in, garbage out. So the machine learning and data problems are notoriously bad because if you make an error in your code, it will throw you an exception. If you make an error in the machine learning model, it will return a number. So, I mean, in sense of if it gets a data in a form that it kind of expects, but the data is totally different data than you expected before, you'll get a number, but it means nothing. So you have to remember about it as well. Okay, how you can work your way around it? I mean, first of all, hire people with different skills. So that's one of the things. And the second thing is, okay, I know you're focusing now. Don't. You can get it on the internet. It's called, it used to be called Big Data Landscape. Now it's called Data and AI Landscape because big data is dead. You just have data now. So I don't know if you know. Basically, you have quite a lot of tools you can use, and I encourage you to do that. Go to your favorite cloud provider, find your favorite tool online for modeling, for data deployment, for model deployment, and so on and so forth. A lot of stuff has been done, and it really, really will help you to move forward, especially if you think about production. Well, there's some data projects in a production fashion. Okay, the other stuff, I jump kind of over with whom we do it to what we're actually doing. So man versus machine, there is a lot of conversation. So we had a talk about it, how AI and how models influence our world nowadays. And actually, this kind of have been done in the past. So if you think about it, and I'm not talking about research, I'm talking about industry now. So in industry, what we're actually doing is we are automating things that people are not very good at or are bored at or are just expensive to use there. So so that's actually very kind of similar to a factory automation, automatization, I think, automation, oh, sorry, to a factory automation that has been done in like 100 years ago. Instead, today, we don't have like a harsh working environment. We have people that have to read, for example, social media. Instead, we can do it automatically using machine learning. And by the way, you can get hurt reading a lot of social media. I don't know if you're into it, but then how people think about the models is a bit problematic, because really what models are is this tree example here. By the way, you remember what was that? You've seen it, so that's Titanic. Yeah, it's not very useful in industry, but basically it's a process. So based on our kind of decisions or based on some numbers, models can say, oh, it's A or B, or the class A or class B, or this is some number, or so on and so forth. So models, basically what they do, they automate relatively easy human processes into code, well, algorithms, statistical models, and so on and so forth. But people kind of think sometimes about the AI or the models as being like something supernatural. We often get like questions like we are monitoring brands on the internet, and questions like, oh, if you can detect the logo, so can you detect if we, for instance, with the beer, if we pour the beer into a glass, can you detect what's beer in the glass? And we no. Can you detect what beer is in the glass if you see it basically in the glass? So well, you can't. So models can do only things that people are able to do, and we have to think how we're actually detecting, because also the human perception is quite tricky. So we also had a question with like when you have like a atypical bottle or something like that, can we detect if it's turned? It's like, yeah, but that's not a label detector, that's a bottle detector then, so that's different model. So you have to think about it. So basically what we have to do is build a factory to some extent that automate relatively simple people tasks which are well defined, and make them to run faster than humans can do, and in kind of more reliable way. I wouldn't say unbiased, because that data can be biased, but more reliable way. All right, and what you can't forget about, it won't be cheap. I mean, probably if you do like simple modeling, like, I don't know, linear regression is sufficient, that's going to be cheap, relatively. You just need a laptop for that. But if you want to go into some fancy stuff like natural language processing or image, that will be expensive. And that's an example you may or may not heard. ExcelNet is I think from Facebook, is a transformer-like model. It's like a kind of BERT on steroids, let's say. And this is what they've paid for training them. I mean, there is no price here, but I can tell you it's quite expensive. I mean, depends, in this article you can read, depends on the estimate on which cloud they did it or which hardware they used. They spent from like tens of thousands of dollars up to like $65,000 for one model training. So this is kind of like one experiment. So that's a lot. And you have to remember about it. If you go into this type of project, you have to remember that they will be expensive, and you have to take it into account. Sorry. Also, you have to remember about the data. So that's another kind of expense people tend to forget about it. And nowadays it's quite cool that you have all the open source stuff or open data sets and so on and so forth. But a lot of time they're good if you're kind of distinguishing golden retriever from Labrador, but not all the businesses are into it. So your business may be into, I don't know, cars or something like that. And so there is no data sets of distinguishing, I don't know, Ford makes of cars or something like that. So you probably will have to construct on your data set, not mentioning NLP, that, for example, Wikipedia is quite cool, but Wikipedia is not the language that people use or social media or in email or something like that. Wikipedia is very specific to how the language is used, and actually you don't have any dialogue. Well, you have some dialogues there, but they may also be ancient. So so you have to remember about it, that a lot of data sets won't fit your business problem. So you have to spend time and money and actually think about it, how to make your data sets when you embark on a data project. And again, that can be also a engineering problem. That's, by the way, open image. No, sorry, that's open image. It's ImageNet, sorry, example. And Wikipedia as well, Wikipedia. So Okay, so you have to assume that there is no data for your problem, and you have to find it. You can use transfer learning and tune your data, but still you will need like 1 or 2 or 10 or really like few thousand examples to be often hand labeled by people. So you have to remember about it. So how you can go around this? So one thing is transfer learning. A lot of existing models for especially for NLP and images. There's a lot of stuff out there. You can use them, but you have to remember that the existing models were most of the time trained on those academic data sets, and they're great at Labradors and great at Wikipedia language, but not necessarily great on your weird social media, very short conversations or single emojis and stuff like that. And also you have existing models, so all the cloud providers, so all the big cloud providers and a lot of smaller companies have some form of AI APIs you can use, and basically you have to know how the REST call works in, I don't know, a language, basically to use them. So it's very simple. So start from there. If you get more fancy, you can go into this AutoML business that you can provide a small data set and train them instead of kind of embarking on full-blown data project, because if you do, you probably sink quite a lot of money into it. So try stuff first, build a hypothesis, test it on existing tools, then embark on kind of longer scale data projects and team building. And also, you have to remember about that, that's the bookshelf part of my talk. You have to remember about that there is a lot of kind of cavities out there and traps for you. And some of the traps are in the statistics, so and maths, you can look into AI delusion or quite controversial weapons of math destruction about, you know, what are the traps of using models in different places and how they are biased and what this can cause on it, but also your enemies yourself. So thinking fast and slow is a great example of how human minds work and how our kind of biases and ill understanding of statistics will kind of mislead you. So you have to remember about that as well. So you have to use things like hypothesis and really scientific method to some extent to actually work in this field. It's not, again, building a house. It's more of a art and science kind of business, and don't forget about it. Also, I want to kind of just scratch a surface with different types of teams, because that's a big area, how to lead the teams of data people, data scientists. A lot of people in the business have PhDs, they're quite creative, and these are quite different teams than, I don't know, factory workers or something like that. So you have to, and a lot of, on the other hand, management staff was built on 19th and 20th century theory of management in like factory-based industry. So they're kind of obsolete. So so you have to kind of move over it. And these are the books I can kind of recommend for you to read. Radical Candor, I think, is a must for everyone in IT. Thinking about how to lead people and how to talk to them and how to make this your communication with your people in an effective way. Creative thing is very interesting. This is from the creator of Pixar. And he actually transitioned from academia to industry, because the stuff that did in Pixar was super new, and that was actually transferring a lot of academic knowledge into industry for the first time. And they have a lot of ideas how to work with super creative people, because the people that work in there, this is like a definition of being creative. So they have a lot of tricks how to do it. And also organization-wise, blitzscaling is quite interesting, though that it's actually very businessy, and how you scale your business, but also how to think about your business in your business size kind of setting. So that's a recommendation. But the bottom line here is those teams are a little bit different, and you have to lead them in kind of more open way, and they have to have a lot of freedom basically to move around. So a lot of people tend to forget about the typical or kind of let's say conservative approach to management doesn't work with these teams and these people. Okay, thank you very much.
Questions? Any question from your side regarding the managing data-driven? Yeah, okay.
Thank you very much, brilliant speech. And have you ever had chance to work with external client on AI or data-related project, or this was always something internal?
No, yes, I did. So not always internal. It was also consultancy products or.
Okay, so what could you recommend to in the way of explaining risk and possible failure of data project to the client?
You have to learn quite a lot of jokes. That's the first, I think.
Good point.
But well, I think what people, I don't think business is unhappy with failure per se. They just want to know. So they want to understand how the failure will work and how you can kind of react to the failure relatively quickly. So long story short, radical candor. so just being basically honest and explain what's the plus, what's the minus, and what you're getting into it. In approachable way. I mean, I think the problem with business is not they don't understand the risk. It's just how we explain it to them. Because often I had this situation. I was talking to a director in a company, well, not a technical guy completely, and he was saying like, oh, we had this data scientist people, and they were explaining like throwing numbers on me, and all I wanted is a list of phone numbers to call clients. That's all. I wasn't interested in that. So how you communicate your certainty or uncertainty and what the business need, that's the most important thing. And I think if they understand what are the steps roughly and what can go wrong, then they're relatively happy with the risk. And also you should be agile in sense of they want to have results relatively quickly. So I don't know, should I say MVP? But basically work on a kind of prototype basis. So you should quickly show them something how it will roughly work. They're not interested that your precision is just 60% or something like 0.6 whatever. But they interested in this is what we will get, and they will kind of assess it. And we also what we did often is we prepared demo for clients that they can use kind of when they come back basically. So basically they can click and use the model, for instance, like with sentiment, and they can chuck some text into it, and they say, oh, this works great or not, or something like that. So just be honest and let them see how your model works, I think.
Okay, thank you.
Transparency for the win, right?
Yeah, exactly.
Okay. So thank you so much. Thank you, Jakub.
Cheers. Pleasure.